All right, this is lab number 6 for week number 8. We're talking about analog devices, math, and comparison instruction, and some common mistakes that people have been making in the labs. So let's look at this here. First thing we're going to start with is this little conveyor right here. So one conveyor with a pusher on it. First thing we're going to do is basically just make logic to run this conveyor. So it's actually got 3 motors, and we're just going to do these 2 buttons right here. So we'll just do that logic there, and we want to have it look just like I'm showing here. So start, stop, belt 1, 2, 3. So let's create that, and I'll show what I'm finding people are doing incorrectly with these things. So I'm going to make my rung here. So this is my seal circuit. So I guess the first thing that I'm going to see is this is called start PB2. It's stop PB2. That's belt 1 down here. Now there's a couple different ways people can do this. I see this a lot. So I'll go through all the different ways you can do this and why I don't like these. So this is one way here. So this is this method here. So without branching your outputs, but by putting them in series instead. This is legal. It will run, but this is not a common way to do this in industry. So this is programmed right now. And we can see this does, oops. Make sure I am connected here. Okay, there we go. So that is running right now. So you can see that does work, but this is not the common way to do this. So other ways that people do this that I don't like, I really want people to get away from using latches. Now you can use latches for this. It will completely work, but again, it is not a normal way to do this. We learn about latches, and then I always regret teaching people how latches are used, because it is not a good way to do anything. So this is if you're going to do it with latches. You could do this. think this is correct here. Oh, that should not be there. So this would be using latches. Again, we don't like this method either. So this is a habit. I want to break this. I saw this done a lot on the tests. And the problem with this is when we start getting more complex logic, you really need to start using seal circuits, because that is the way that you'll see things done. In industry, you won't see latches used like this. They're kind of a crutch to get you through not really understanding how seal circuits work, but we need to start using seal circuits for everything. So this is a method of doing it, but it is not very good. So let's go back to our seal. So let's delete that. And let's go back to creating that seal. So start is there. Belt 1 is going to be down here as well. Stop is up here. Now here's where people get into some trouble doing their seal circuits. There are ways you can make these branches. And this is commonly what people will do. They'll make a branch, and then they'll add another branch in like this. And you can see what this is doing. This is called cascading your branches. And we don't want to do this. This causes a problem. So you can see how this is kind of stepped down, and those are actual individual branches there. So this is valid, and this will run. You will see that if you're getting a lot of outputs, you're trying to turn on with the same logic, and you're trying to do this for a lot of things. I think this cuts you off after 7 branches. And there is a difference in the way this scans in the PLC versus the way I'm going to show you in a second. So cascading branches is not a good thing. For a couple reasons like that. So it looks very similar to what I'm about to show you, and you'll see this does work fine. So that does work fine. But this is not the best way to do this. The best way to do this is to actually extend these branches. So if you click here and then do a right click, you'll see you get an option here to say add a branch level. And that is what you want to do. So see how that comes down square as opposed to stepping in like that? This is what you want to do. Adding a branch level lets you just keep extending that indefinitely. And that is the way we would like to approach this. So this method here is what we're going to call the correct way to program this. Okay, so that is the best, most correct way to program this right now. So seal circuit with those extended branches like that. That is the way we'd want to see this done. So lots of little differences there, but this is the most correct way to do it. This is the way you would see this done. In industry, this is the way that would follow industrial standards. Okay, so that's that part. Let's look at this pusher right here. Now this is a problem people get into as well. So we're going to control this pusher off of these 2 switches here. So this is 2 separate switches that I'm going to use to control this. So I'm going to have one that says advanced pusher 1, and if I have that, I'm going to advance my pusher solenoid. And then I'm going to have another line of logic here that's going to say, I also want to have this one here control it. So I'm going to use that same output, and I'm going to use advanced pusher 2, which is the second switch over here. So this is something that people that are learning how to program will commonly do, and I'll show you why it is wrong. So what is going on here now is we have two separate lines of logic that are controlling the same output. So you can see this, I have a line of logic here controlling this output, a line of logic here controlling that same output. So here is my problem. I turn that one on. I have an input. I have an output. Everything we've learned so far says that if you have an output and you have all of the logic to the left of it is true, which is my case here, then this output should be on. But that output is not on. It is off right now. So how is that possible? If you just look at that line, you would say this output should be on right now, but it's not. Why is that the case? So the problem is that you have two separate lines of logic trying to control the same output. And this happens to people all the time. And basically what you're doing is you're duplicating an output. You're using it twice on two separate lines. So you have two different sets of conditions that are fighting over control of the same output. And basically what will happen with this is whichever line of logic happens last is the one that you're going to see the result of. So because this line here is scanned last, it is the one that is ultimately going to control that output. So if I was to switch these switches the other way and turn this output on, you'll see in this case now, this one actually turns it on because this one happens last. This is the one that actually controls it, and now we have output is on even though the logic to the left of it is false. Okay? Now, even if we took this, if we swap the order of these, you'll see it's the exact opposite case here. So in this case here, basically this switch had all the control. This switch didn't even matter. If I swap the order of those two rungs, it'll just be the complete opposite case. This switch here will have all the control. This one won't even matter. So now it's just the opposite case. It's this one here that has all the control. That second one doesn't even matter. So how do we get around this? I have two switches here I want to be able to use to control this output. So how do I actually make this work? Well, the solution is actually pretty simple. Basically what you need to do, you can only have one line of logic with one output, but you can just branch these two inputs like that. So you're making an OR condition. So really what you want to say is that if this input is on or if this input is on, turn on the output. Because that is really the condition you're trying to create here. But you can't do it on two separate lines of logic. It has to be combined into only one line. So let's watch this. So that one has control, and this one has control, both separately, because we're now doing this on two different lines like that. So those are common mistakes that we've been seeing so far, and that is the first part of this week's lab.